Hello everyone. So आज हम सीखेंगे implicit differentiation. We have already done implicit differentiation in MME1 and now we will try to look at implicit differentiation from the viewpoint of a function of two variables. So let us start. So first we will be looking at a normal equation of a function of two variables, and then I will tell you how to find out the relationship between the partial derivatives and the derivative itself. So if you remember, we have done equations where y cannot be expressed explicitly in terms of x. What does it mean? So for example, if y is equal to x square, so we all know that dy by dx equals to 2x. Okay. But suppose you had a situation like this where xy plus y cube is equal to 1. Okay. Then we were taught implicit differentiation. What is implicit differentiation? Implicit differentiation means that your y cannot be expressed in terms of x explicitly. You will not be able to express y in terms of x. You will not be able to separate y over here. So in that system, what we used to do, we used to differentiate the whole equation. Okay. So we used to differentiate the whole equation. Now, what do you mean by that? Obviously, over here, y was supposed to be a function of x. Okay, because we were calculating f dash x, where f dash x was dy by dx. So what did we used to do? Please pay attention. So we used to do d by dx of the whole thing, and that is d by dx of 1. So it is x dy by dx. Now, in the first one, I will be applying chain rule, product rule of derivatives. So x into dy by dx plus y into dx by dx plus in y cube, we will have first the power rule, that is 3y square, and then dy by dx. And then dy by dx of 1 was 0. Okay, so we had x dy by dx plus y plus 3y square dy by dx equals to 0. So that would imply that x plus 3y square dy by dx was equals to minus y. And that would imply dy by dx is equal to minus y upon x plus 3y square. And dy by dx was f dash x. So this was the concept of implicit differentiation. So when we could not express y explicitly in terms of x, we used to differentiate the whole equation in terms of x, okay, assuming that y is a function of x. And then we used to apply all the rules, product rule, quotient rule, chain rule. Then we used to collect terms containing dy by dx on the left and the other terms were moved to the right. And then we used to get an expression for dy by dx, okay. Now let us look at this from another point of view. So if you remember that our question was x plus y cube equals to 1. So if you look at the left-hand side, the left-hand side is a function of two variables, x and y, and this right-hand side is equal to 1, okay? Where y is a function of x that we have to assume, okay? So now if you look at this function fxy, this function is a function of two variables, okay? So this is my z. That means my figure or my diagram will be a three-dimensional object. But over here, z is equal to 1. That means I am dealing with a level curve of fxy. Okay, so I'm dealing with a level curve of fxy. What do you mean by level curve? So whenever I give a constant value to z, that is fxy, I get a 2D diagram. Okay, and when I talk about that 2D diagram, when I talk about the derivative, that is actually the slope of the tangent at a point. So for example, if this is your 2D representation of a level curve, and if this is the point at which you are calculating the derivative, then it is nothing but the slope of this particular tangent. Okay, now, so basically what we are dealing with now, we are dealing with level curve. So I am dealing with level curve of fxy, xy plus y cube over here, and the level curve was c equals to 1. Okay, so now let us look at this function from this point of view. So your fxy is equal to 1. Now your y is a function of x, so y is equal to fx is equal to 1. Okay, so now differentiate both sides with respect to x, and now we are going to apply chain rule of derivatives. Okay, so basically what we are going to do, so we are going to do del f by del x. So we are going to differentiate f with respect to x, okay, and then this is going to be x fx, and the first d by dx of x, so d by dx of x, and then we are going to differentiate f with respect to y, where y was your fx, so that is x fx, and then you will do dy by dx. Okay, and the right hand side will be d by dx of 1, that will be 0. So it is going to be fx x fx into 1 plus fy, the derivative with respect to the second variable, x fx, and dy by dx is nothing but f dash x. Okay, so if you write f dash x now, f dash x is going to be minus fx x comma fx whole divided by fy x comma fx. So this is how we obtain the formula for f dash x when we know that fxy is equal to some constant. So here it is equal to 1. So we can generally assume the curve to be of the type fxy equals to c, which is a level curve where c is a constant. Okay, so this becomes my formula. Obviously, the assumption, underlying assumption is that the derivative with respect to y, the partial derivative of f with respect to y cannot be 0. Okay, so now let us look at this particular example from this point of view only. So we had xy plus y cube equals to 1. So your fxy was xy plus y cube. So your dy by dx as per the formula should be minus fx xy divided by fy xy. Now, what is the partial derivative with respect to x? So when we are differentiating with respect to x, so the derivative of xy will be y and the derivative of y cube will be 0. And what is the partial derivative with respect to y? So the derivative of xy will be x and y cube will be 3y square. Now let us see what we had derived in the first page. So if you see, we have got the same formula. So that means whatever we were doing till now, whatever differentiation we were doing till now, we were actually dealing with chain rule of derivatives for a function of two variables. When that function of two variables is equal to some constant, that means when we are dealing with level curves of a particular function of two variables. What does it mean? It means that when whatever level curve I'm getting, and if I want to calculate dy by dx at suppose 1 comma 1, so that is nothing but the derivative of the level curve at that particular point 1 comma 1. So this is implicit differentiation. And now let us try to do some questions from Seder and Heyman. Compute y dash when xy half is equal to 2. So x y power half is equal to 2. So this is my fxy equals to c form, where fxy is equal to xy power half. So then your y dash means dy by dx. So y dash will be nothing but f dash x, which is dy by dx, all the forms. And this is equal to minus the partial derivative with respect to x divided by the partial derivative with respect to y. The partial derivative with respect to x will be y power half. And the partial derivative with respect to y will be, x will be treated as a constant into half y power minus half. Okay. So it is going to be minus, and then y power minus half goes in the numerator. So y power half into y power half divided by x, and then 2 also comes in the numerator, which is minus 2y by x. And if you want to verify this using your previous knowledge, so if you see that your x power x into y power half was 2, so differentiate both sides with respect to x. So this is going to be d by dx of this. Then use the product rule. So x into y power half का differentiation half y power minus half dy by dx plus y power half को ऐसे लिखेंगे into 1, and this is 0. So dy by dx will be now minus y power half upon x y power minus half upon 2. So we are again going to get minus 2y by x. So that is the beauty of chain rule of derivatives for a function of several variables. Okay, let us do one more example. So for the curve given by x cube plus x square minus 2y square minus 10y equals to 0, this is the curve. Find the slope of an equation for the tangent at the point xy to 1. Okay, so what is my fxy equals to c? That is x cube plus x square y minus 2y square minus 10y equals to 0. So this is my c, this is my fxy. So y dash will be minus fx divided by fy. So let us calculate the partial derivative with respect to x. So that will be 3x square plus 2xy, and then with a negative sign divided by the partial derivative with respect to y, which is x square into 1, x cube का derivative with respect to y 0 हो जाएगा, minus 2 into 2y minus 10. So y dash, so ऊपर से negative sign को नीचे से cancel कर लेते हैं. So we are going to have 3x square plus 2xy upon 10 plus 4y minus x square. This is the derivative. Now they are saying find the equation of the tangent at the point 2 comma 1. So that means we need slope of tangent. So we need slope of tangent at 2 comma 1. So यहाँ पे x को 2 रखिए, y को 1 रखिए. So 3 into 1 plus 2 into x is 2. So 3 into 4. 2 into 2 into 1 divided by 10 plus 4 into 1 minus 4. So slope of tangent at 2 comma 1 will be 12 plus 4 divided by 10. So which is 16 by 10, which is 8 by 5. So now what information do we have about the tangent? The tangent passes through the point 2 comma 1. So whatever your curve is, suppose your curve is like this, the tangent is at 2 comma 1 and the slope of the tangent is 8 by 5. So what is the point slope form? Y minus y1 equals to m x minus x1. So y minus 1 equals to 8 by 5 x minus x1. So x1 is 2. Okay. So 5y minus 5 is equal to 8x minus 16. So 8x minus 5y minus 11 equals to 0. So that is how you find out the equation of the tangent. Okay. Let us look at another example from the readings. So, okay. Assume that the equation e power xy square minus 2x minus 4y equals to c defines y as a differentiable function fx of x. Find the value of the constant c. Set that f0 is 1. Compute y dash at xy equals to 0, 1. Okay, so f0 equals to 1 means x equals to 0 and y equals to 1. Why? Because y is equal to fx. So when I put x equals to 0, I get y equals to 1. So that means I have to put the values over here. So so 0 into 1 square minus 2 into 0 minus 4 into 1 equals to c. So e power 0 is 1 minus 0 minus 4 equals to c. So c is coming out to be minus 3. Okay, so my equation is now exy square minus 2x minus 4y equals to minus 3. So this is my fxy and this is my c. So I want to find out the derivative y dash. So let's calculate the derivative. So, okay, so we've calculated the value of c and y dash at 0, 1. So y dash will be minus fx divided by fy. So y dash will be now differentiate this particular function with respect to x only. So the derivative of e power something is e power something. And now differentiate xy square with respect to x, which is y square, minus 2, differentiate x with respect to x, which is 1, minus 4y, that is 0. Okay. Now divide by the partial derivative with respect to y. So e power xy square, now differentiate xy square with respect to y, that is x into 2y, minus 2 into 0, that is 0, minus 4. So y dash should be 2 minus y square e power xy square whole divided by e power xy square multiplied by 2xy minus 4. Okay, this is my derivative. And now I want to find out the value of derivative at 0, 1. So put x equals to 0, y equals to 1. So if you put x equals to 0, so this is going to be e power something 0. 0 into something is 0. So, so 2 minus 1 square into 1, because e power 0 is 1. So 2 minus 1, which is 1. And then this whole thing becomes 0 because 2xy, 2 into 0 into something is 0, minus 4. Okay, so the slope is minus 1 by 4. So knowing how to implicitly differentiate using a direct formula for a function of two variables using the concept of level curves helps you a lot, saves a lot of time, and you see the underlying concept. The underlying concept is partial derivatives and chain a rule for a function of two variables. Thank you very much.